It's my great pleasure to be able to introduce our final speaker in the final session today. Devanshi Vyas is one of the co-founders of Censius, and she's going to be talking about pitfalls of large language models in production and how to solve them. Censius, her company, is an AI observability platform that helps optimize AI model real-world performance. She's a seasoned ML practitioner and recognizes the significance of enterprise-level observability to help companies solve complex challenges in AI development and incorporate AI into production successfully. She's worked with customers and AI teams across a number of industry verticals, and she's a strong advocate for building transparent, reliable, and compliant AI solutions. Over to you.
Hello, everyone. Thank you for being here. Very happy to see you here. Thanks, Charles, for the introduction. As he mentioned, I'm Devanshi. I'm the co-founder of Censius, which is an AI observability platform, and we help improve and optimize model performance for data science teams across enterprises and startups. So for our topic today, we're going to talk about large language models. We're going to talk about how they have grown in scale and how these massively complex models are both our best friends with huge potential. There's a lot to gain from them, but they can also be kind of unpredictable and fall into kind of the frenemy camp. We will explore the quirks and conundrums of biased AI and how this can occasionally lead to hallucinations, which sometimes can also put conspiracy theorists to shame. On a more serious note, let's continue this conversation and deep dive into the different risk mitigation strategies that we can use to improve these improve the performance of these LLMs in production, how we can fine-tune them, prevent model decay, optimize their performance, and minimize the impact of their failures, especially for customers who end up bearing the brunt of this in case this is put out to production. All right, we already went over this, and so yes. Just to go over the agenda for today, we're going to talk about large language models, where we are today, and where do we go from here, what kind of problems we might face in case we're using them in production, and how to make sure that we mitigate risks. And also, what kind of framework do we have to think about in case we're looking to incorporate these in production. And we'll probably spend like a minute on how we're trying to solve this problem at Censius. All right. So at a glance, should we proceed with caution? So we know that generative AI today has created this perfect storm of rapidly growing ML growth, and that is leading to a lot of advancement of large language models. And as the usage of large language models grows, or has grown over the past several years, researchers keep on developing newer and larger architectures. And this new scale of adaptability makes these models more flexible and also useful for a broader range of use cases. And so possibilities are endless, if you think about it. But as these models scale in size, we also look at newer and newer problems or roadblocks when it comes to incorporating these. And there are a few that we can think about right off the bat. So one is definitely computational resources. As we all know, bills can add up quite quickly. Actually, just a question. How many of you here have used a large language model in practice? So quite a few. How many have actually used an observability platform? Yeah. So this is kind of the biggest problem that we have. There are only a couple who think about how we go from testing something cool out and seeing whether it works for a use case to actually putting it out to production where it can be used by our customers. And this is a gap that gets more and more glaring as these models grow in size, and you have less and less control over what actually goes in training these models. And I think a lot of people that I've talked to end up saying that, oh, we have decent budget, we can get the best model currently out in the market, but the best model keeps on changing. And what do you call the best model? Because it's relative. And it depends on what test they're saying. Like today, it's ChatGPT. Tomorrow, it's Falcon. Then it's Llama. You can't keep changing all of these in production every single day. And there's a limit to how much resources you can actually put to this kind of testing before you move it over to production. So currently, the tools that we have are very good if you want to stitch together a shiny demo with, with access to APIs that you can pay for, and if you want embeddings, you can have Pinecone or something like that as your storage solution. But the problem still remains in how you're going to be able to actually put this into a pipeline where it's ready for production and it's reliable. So definitely cost is a big concern, and it gets more and more pressing, especially for smaller companies that have limited resources and limited people who would benefit the most when it comes to using AI. And then because these models are so large and you don't really control what goes into it, you don't really know what is going wrong if you see something that is off or something that does not make sense for you. And because of this, it takes a long time to go down that rabbit hole, and there's a higher turnaround time for issue resolution. This increases, obviously, operational costs, technical debt. The more you use things you don't understand, technical debt keeps on climbing, and it doesn't seem as rosy as it initially does. Obviously, things that we're very aware of: misleading, inaccurate information. There are a lot of biases that can creep in from the training data. It could creep in from how you are. We'll talk about bias in more detail in a few slides. But it's OK if your model goes wrong in a demo like this. But if you're actually servicing real human customers, there's a very small margin of error that is acceptable. And so there's definitely something that needs to be done to make sure that our models are unbiased and reliable. And these kind of things end up leading to customer trust issues and customer attrition. And obviously, there are ethical and legal considerations based on where your company is situated. Some are basic human ethics that you should take care of, and which sometimes models hallucinate and don't really fall very clearly in the boundaries. So as we go forward, this is something that we, as industry practitioners and technical leaders, have seen that although there's a lot of interest in trying to use AI and integrate AI in their pipelines and their products, it's still pretty hard. And it is also resulting in bottom line dollars lost. So there are concerns when it comes to whether they're biased or not, how privacy and fairness is affected, but also this is survey by McKinsey that reported that 55% of leaders report financial losses and increased customer attrition because of incorporating AI. Because initially, a lot of companies rely on their own data, which is their own secret sauce, to ensure that they have a competitive edge. And also, there is this inherent belief that there's a human in the middle that's making sure that something is not going wrong. As we become more and more reliant on AI, if we don't take the necessary measures to ensure that we have observability in place, we lose that sense of security, and we expose our customers to these gaps, and that eventually affects the bottom line. So the biggest question right now is, as we all know, LLMs have a lot of hype going on. Even my dad knows about ChatGPT. So literally everyone on the planet pretty much knows about this. Everyone in tech knows about it. Everyone wants to incorporate these. I'm talking to a lot of enterprise leaders who are sort of under the umbrella of, oh, we want to use AI. We just don't know what we want to use it for, but we definitely want to use AI, and we want to be AI first, we want to be AI enabled, and we also want all these shiny posts on LinkedIn. It's very hard to answer these questions with a straight face when you sort of are talking to them and are like, I think it's more important that you figure out why you want to use it and what do you want to use it for, instead of just putting it out there that you are AI enabled. But we do understand that there's a lot of hype, but we need to understand whether this is going to continue, if this is something that LLMs are going to keep pace with the kind of, I guess, halo that they have around them with respect to what their capabilities are, what all problems they can solve. And there's a very interesting study by a team from Stanford and UC Berkeley, and they wanted to see how the behavior of these models develops over time. And it's interesting to see that ChatGPT, that is the model that they used. They compared two versions, ChatGPT and 3.5, ChatGPT, GPT-4 and GPT 3.5, and they observed their behavior over a few months. And what they found was that overall, the behavior of the same LLM service, they're not pitting them against each other, they're pitting the same model against the same model for the same question and the same prompt, and that is changing substantially in a relatively short period of time. And it's getting worse. So that's the problem. And this highlights the need for continuous monitoring of LLMs. So I don't know, it's probably hard to see, but so this is between March and June. And GPT-4, the accuracy drops from 83.6% to 35.2%. So that's a 48.4% drop in accuracy. That is a lot, especially given how many dollars you have to spend for GPT-4. It's obnoxiously expensive. And it also gets more, the verbosity drops, and so you don't really get good answers. So the question basically that they ask is how many happy numbers there are between a given interval, and they ask it to do it step by step. And GPT-4 does go up a little bit in accuracy, but it just doesn't follow the same kind of verbosity, and it just adds too many more steps, which are unnecessary. So this shows that we'll talk more about drift in a bit, but the model is drifting, and it's drifting a lot. And unless you actually monitor how it's doing for your own use case, you will never know this. This is a dedicated team of researchers amazing ML practitioners who are actually investing months in this research and publishing this. But if you're not doing the same, if you feel like, oh, I got this model from the best provider, and I'm paying them a good deal of money, so I'm good to go. I don't really have to check how the model is doing. That's not really the case. And such a big drop in accuracy is a big problem. Moreover, when it comes to computer code generation, both editions' ability actually went down. And we can actually dive a little bit deeper. They also tried to see how it's doing in terms of prompting. So if you can read, COT is chain of thought. So in March, when they tried to do it without any prompting versus prompting, they saw an uptick of 56.6% in GPT-4, whereas GPT 3.5 actually did worse. But in June, there was an uptick of only 3%. So it's not even helping when they say, like, oh, if your model is not doing well, follow XYZ steps. Even following that is not a guarantee that the model is going to do well. And GPT 3.5 ends up doing better, but still, the model, they also wanted to sort of understand how the model is doing, so there's a confusion matrix in the bottom. I would highly recommend everyone to check out this paper. It's very interesting because I think a lot of people end up spending time looking at all the results of all these companies who are in this race to build the best LLM, and a lot of highlighting is done on the fact like, oh, ours is the fastest, ours is the best, we're trained on bigger data, we have these many parameters. But there's not enough research being done on how these are doing over time, how reliable they are, and how much they can be trusted when it comes to production. All right. So there are a few things that we need to think about when it comes to pitfalls of LLMs. These are the ones that we're going to discuss today. There are more, but these are the first things that I would suggest you take a look into and see how you're using models today and how you can improve them over time and get the most bang for your buck, basically. The first is garbage in, garbage out. We know how important data quality is in terms of determining the quality of the result that the model produces. The predictions made by the model are as good as the data that it is fed. And garbage is a broad, ever-expanding term when it comes to data science, but basically any data quality, any data that is not good enough to be fed to your algorithms, whether it is poorly labeled, whether it is inaccurate, and shows and reflects underlying human prejudices or is incomplete, doesn't really mirror what they're going to see in production. Also, a lot of legacy software dependencies can lead to siloed collaboration, and this ends up increasing the turnaround time to resolve issues. And the downstream impact of this could be higher costs and overall increased time in trying to manage and monitor it. The second is the most, I guess, widely spoken about these days, which is hallucination. And hallucination is basically when the model just fabricates responses. This can lead to spread of misinformation, expose confidential information, and generally creates unrealistic expectations of what LLMs can do. One example could be if you ask a model, what is 2 + 2, and it says 5, it is hallucinating. It's not following whatever math it has learned. And sometimes, interestingly, LLMs are also very convincing. So they will justify if you ask it, like, why did you say this? Oh, this is because X, Y, and Z, and this is correct. So it just continues from there. And there's also an example on the side, which is related to Ebola. And you see the two outputs are hallucinations, but they're kind of different. One is because it clearly sees in the source paragraph there is an answer to the question it is asked, but it chooses to ignore it. And in the second one, there's no information related to it, but it, instead of saying, I don't know anything about it, which is a response that LLMs do give, like if you ask ChatGPT something that is more current, it will say, I don't know about this because I was trained last in 2021. This is a more current issue. You might want to do a Google search or things like that. So instead of that, it is choosing to give information that is incorrect. And the third one is something that is kind of an untapped potential when it comes to AI in general and large language models. Drift. So drift occurs when models initially trained on a particular data set gradually begin to diverge from the original course. This happens a lot when models are trained on a limited test set, but are used in a production environment, which is very different. And because of this, the training data did not really reflect the production data very well, and the model tends to drift. So there are three kinds of drift that we see. So one is a data drift, which can be observed due to changes in the statistical properties, such as feature distributions. The second is concept drift, where the law underlying the data changes, and so assumptions that the model initially had have to be updated. For example, if you know the food and the FDA basically has a list of items labeled generally regarded as safe, which is called GRAS. And a lot of times new data comes out. For example, aspartame is the latest one, where there are new findings with respect to it being a potential carcinogen. And so in those cases, it's a concept drift, because you now have to go back and either update the training data, update the assumptions that it had made, where it was saying that, OK, this is safe, or when you look at a particular food that has that ingredient and it says that, OK, this is safe because it has the ingredients which are all safe, now it has to put up an error sign or like alert you that it might not be safe. So that's an example of concept drift. There are also upstream data changes, especially, for example, if there's a company that operates in the US and then has to operate in the UK. They use different measurement systems, so we'll have to update pounds to kilograms and miles to kilometers. So those are generally what cause these drifts. So the third, I don't know, this is the fourth one, but bias. Bias is something that we talk about a lot, and something that we want to safeguard against the most, because as we know, we don't live in a perfect world, and a lot of bias tends to creep into the models that we build, and we need to make sure that our models don't make the same mistakes we have. And there are two kinds of biases which can cause model failure. And we have to understand both of these to make sure that we're avoiding unfair, inaccurate outcomes for both these cases. So the first is human bias. This is where a model is kind of like a sponge. It soaks up the shortcomings of developers that are developing the model and whatever knowledge they're feeding it. And this can generate from cognitive error, flawed information processing, and preconceived notions that are ingrained into the model, and taints the model's ability to generate fair, balanced output. The second one is algorithmic bias, And this occurs when the model's behavior is unfavorable towards specific aspects of its users. And this could be due to flaws in the training data. The training data did not really mirror what production sees, and it's impossible to achieve a neutral model if the training data does not represent the users and situations that it's going to be exposed to accurately. And the other could also be context. If context is transferred or changed, it might result in deviation from whatever statistical or moral standards that it was initially set with. And there's also due to interpretation, so there could be a difference in the interpretation of what the model thinks the user needs and what the user is asking for. And in this case, the user could either be a human or another component of the system. So here are some instances. One is Sparrow, one is Anthropic, and they tend to have ideals which could be controversial. And ideally, in these cases, they should say, I don't know. But they do. So for example, here's another example of what could be bias. It's actually a little bit of both, because first, the prompt is wrong. So the human is asking for something which is controversial. And it's also giving an answer that is controversial. So we have to be very careful of what we ask, and also of ensuring that we don't just use whatever it outputs, because it affects a lot of people. All right. The last one is lack of human reasoning. Sorry, it's like a little bit cut off on the top. But let's say that your model hits a bump in the road and performance just takes a nosedive. But you don't know what went wrong or what caused it. So traditionally, we try to assess the efficiency of our models, doing some manual testing. And if we have not built the model ourselves, then we don't really have a clear view of how the model is handling different sets of data. And there's no way to pinpoint specific cohorts of models of the data set that is underperforming. For example, if you have a model that is used by a bank that tries to suggest whether you should give this loan to this person or not, and overall, it was doing fine, but the accuracy has dipped. Now, the accuracy, it's hard to know how it has dipped if you don't see different cohorts. Like, is it a specific state that is not doing well? Is it a specific subset of users that are being adversely affected, whether it's people of color, whether it's a certain age group, whether it is particular gender. You should have the ability to assess this over different cohorts and over different subsets of the data to understand how it's doing on average. Because sometimes, actually, it does not even do bad overall, but it really does badly for a certain cohort. And as a company, you should make sure that your product is working well for everyone. It's not just working well on average. It's working well and without any bias for any kinds of specific cohorts. And if there is no traceability, to know how the model is doing, how to follow down this path, we're just left with playing a guessing game. And it's difficult to explain the inner working of any black box AI model, whether it's to stakeholders or customers or your own team members. So it's basically like trying to solve a mystery without any clues. And this is fine if you're doing this on the side, but if this is a real world use case, we need to be more accountable. So what do data science teams really need? So we need to know what kind of oversight our model has, and we need to know which tools to use, which processes to have to ensure that we can identify and resolve issues in models, and we can ensure accuracy and reliability. And we want to make sure that we solve our problems in an agile way, because we need to resolve our issues rapidly, and we also want to make sure that we adapt swiftly to evolving data challenges, because there are going to be new and new challenges as we embrace new and new models, new and new architectures, and there's a lot of unseen territory that we're being exposed to here. And yeah, we need to make sure that we can get from test to market faster. We can build this pipeline and mitigate risk, and also ensure any compliance, especially now we know that governments are also pretty interested in trying to understand how they can ensure that these models are compliant. And there are going to be more rules governing them, so we want to make sure that any new use cases we set up are compliant. Oh. Okay. No. Sorry. Okay. Yeah.
Can you do it manually from your screen? Sorry.
Yeah, no worries.
Drop out present mode.
That's really weird. It's not
Just,
working.
yeah.
Can you go to the screen, the extension?
Yeah. Here. Let me just keep it like this.
To go to that screen.
Yeah, I'm at that screen, so. But it's, yeah. Okay, I'll just scroll.
You can maximize if you want, and it's gonna be
Yeah, it's fine. All right, sorry about that. So when we talk about a framework for continuously optimizing and building reliable LLMs, this is what we have to think about. We have to understand how our model is performing. Is something going wrong? Then we should know about it. And so for that, we have to ensure that it is something that we are monitoring. And when something is going wrong, are we able to tell what is going wrong? Are we able to explain what the root cause is? And the third is troubleshooting. Why did it go wrong? Because we want to make sure that this is not something that happens again and again. And we're able to debug and fix the root cause, so we're not going back into this cycle of problems where we don't know what to do. So for example, if it's a summarization use case, we can think about ensuring that we have embedding visualization. In this case, we need to know what kind of metric that we use for ensuring how we compare the different embeddings. So the tracking metric here is the root score. This is an example how we have built it for Censius. But understanding how the different summaries are doing in terms of the root score, whether you can get alerts for that so that it's not something that is offline where you test it and then after a week you realize it was not working in the first place. So you want to make sure that you have real-time alerts for it. You can also extract metadata features. You can understand how it is doing, for example, whether it's sentiment, whether it's text complexity, what kind of language it is, because we need to get out of this idea of monitoring models like we do software. It's not enough to just monitor whether the model is giving a response or not. If you have a summarization task, it's not enough to say, hey, is the summary 3 sentences long or not, or does it have 100 characters? Because that is not what the summary is going to be used for. What it says is a lot more important. And you also want to see, for example, how it is doing with respect to the metrics that matter the most to you. So for example, out of vocabulary words are spaces where most hallucinations can occur. So you could map something like out of vocabulary words with your tracking metric like root score and see if they are working in tandem. For example, if your out of vocabulary words go up, is your root score dropping? Then that means that you have to augment the data that it is trained on, so you can fine-tune the LLM. You can do more in-context learning or retrieval augmented generation, and make sure that this metric tends to be loosely coupled instead of such tightly coupled. And yeah, numbers don't lie. It's not a feeling. It's not about, oh, I spot-checked 5 summaries, or I spot-checked 5 points out of thousands that I'm generating, and they look fine to me. We need to ensure that we take a broader overview of what the model is doing, how it's performing, and understand how these different metrics and the features that matter the most, whether it is toxicity, complexity, are actually performing when it comes to the model. And this can also be used when you compare different models, when you're making a decision as to whether you want to use model A, model B, model C. Then these are the metrics that you can use. Obviously, set up reasonable thresholds, understand the severity, because not everything is P0. If everything is P0, then nothing is P0. So we want to make sure that we understand the hierarchy of what is a big problem, what needs to be solved first. And yeah, so the key takeaways that we have are a lot of things can go wrong while scaling a large language model. And we always have to remember that data is the gold. There are a lot of things we can do, whether it means visualization, tracking care of health to ensure that you are getting the right ROI for the amount of money that you're investing into using these large language models, and you can constantly improve that. It's not a one and done kind of a thing. And constantly monitoring it, having an observability tool in your toolkit can really help make this process faster. Yeah, and that's also a lot of these things are something that we do at Censius. We have a lot of blogs. If you have any questions, you can come to me. But irrespective of what tool you use, I think it's really important that you understand that as we move into this new world where there are going to be a lot of off-the-shelf models that people are going to be using, we need to understand how to at least ensure that we can say whether this model is solving our problem correctly and reliably over time, because this is what is going to affect the bottom line the most. Yeah, and that is all for me. Thank you so much. Sorry for the tech problems, but yeah, hopefully you got something out of use of this. Thank you.
Thanks, Devanshi. I think we've got time for one or two quick questions if anyone's got one.
Hi, thanks, Devanshi. It was nice presentation.
Thank
I
you.
just had some, if you could put in more insights around the black box piece of, the models. We are tending to use LLMs and deep learning for that matter, and interpretability always is a question. So if you could combined with what you've mentioned in terms of observability of the data, how can we also at the same time ensure in combination with explainability, if you can?
Yeah, that's a good question. I think explainability is a metric that should definitely be tracked. So one is SHAP scores. You can use SHAP scores with respect to your different features. And you can also have local explainability. So per data point, where you can see how it is doing locally and how these different features are working in tandem with respect to other data points. If you see a violation, for example, I can also show you an example. So overall explainability and along with local and cohort explainability should give you a lot of insight with respect to what kind of issues your model is seeing and what kind of features you need to augment. And for example, if you have fine-tuned model and you're using a certain kind of data to augment it, then you can see which kind of features are affecting it negatively. And so you can ensure that you have more data points with respect to that and expand on that so your model can become more robust.
Would Shapley work on LLMs particularly directly? No, right?
No, so for LLMs particularly, you can only do meta feature extraction to understand, because if you're using it out of the box and it's just prompt response, then you will have to do some kind of visualization with respect to embeddings and also some meta feature extraction to understand how, based on your use case, it is doing. But if you have fine-tuned model, then you can do more explainability. Yeah.
Hello, hi.
Hello.
It was a really fascinating talk, thank you. I think
thank
you've answered a little bit of my question already, but I was wondered if you could give a bit more color on a certain area around about model patching. So I sort of get the idea that you sort of track a model in production, you're sort of tracking key metrics, you sort of see when it's degrading, and then you root cause and you find out what are the key error modes that you have. But then what? How do you ensure that you correct these key error modes without necessarily negatively impacting performance elsewhere or across the board?
Yeah. So I think a few things that you can do is you start with the vanilla model, off the shelf. You use it. You see where it's going wrong. But then based on that, you can sort of understand based on your resources, your budget, and everything, whether you want to do fine-tuning. You have data for that. For example, if you're using an off-the-shelf model, but you're using it in a legal environment, then there's a very high chance that it's not doing very well. So then you could either fine-tune it on your documents or use some prompts for example, in context learning, or you'll have to build a bigger pipeline, something like a retrieval augmented generation, where it also tries to see, for example, if your model is hallucinating a lot, then you would need a data store with documents, maybe stored in Pinecone, and then every time it also fetches the source, so you understand where exactly the problem is. Because it could be that, for example, you have a legal LLM, and it's doing particularly badly on immigration, for example. And so that's somehow you can trace, and then for that particular kind of branch, you can use more RAG, basically. Does that help?
Right, I think we haven't got time for any more questions, but I'm sure if you can catch Devanshi at the networking, we'll be happy to take more questions. So we just thank her again.
Thank you.
Now, before you all head upstairs to see who won the competitions today, I'd just like to thank all the speakers, the volunteers, the sponsors, and particularly the AV team for their support today. If we can give them a round of applause. As I've said, there will be networking and beer at the bar after the competition is announced. But if you've enjoyed today, date for the diary, May the 18th is the next DSF festival. Okay, thank you so much for today.